All right, welcome to Chapter 7, Section 6, called Inequalities in Two Triangles. This is for Integrated Math 2 or IM2. So a couple things you'll see on your screen here. The first thing you should see is a due date on your student screen. You don't see it on my teacher preview, but it should be there for you. Number of attempts is always unlimited, so you can do this unlimited times for tests, homework tests and quizzes. Number of questions just lets us know how many questions are on this assignment. Best score is always, whichever attempt is the best one is the one you get to keep. And partial credits enabled. Normally, you have more than one question, so if you answer more or one correctly out of so many, you get partial credit. But for this one, it's, one of one. Once you start your homework, you need to finish it before you can work on anything else. So that means once you click Start here, in the bottom right corner, you will see the Submit Assignment button. You need to make sure that you click that Submit Assignment button when you want to leave this screen. So with this one, there's only one question, so hopefully you finish the question before you click that Submit Assignment button. But if not, still click it so that the system doesn't lock you out, because otherwise it assumes that you want to leave the attempt open, and remember, you have unlimited attempts, so there's no reason to do that. Just make sure you click the Submit Assignment button, and it will also give you credit in the grade book once you click Submit Assignment. So if you forget to click that button, it's not going to show your teacher you've been working on anything. On the side here, you have explanation, example, and message center. So explanation literally gives you the answer to this assignment, this actual question. So it's going to tell you you're going to lose your question attempt because it's not going to give you the answer and then let you come type it in. Example will explain to you exactly what it is we're going to be doing here, and I'm going to talk about the Hinge Theorem here in just a moment, and the converse of the Hinge Theorem, because that's exactly what we're going to be working on. And then down below it shows you kind of how we're going to be typing things in. So you can close this, you can open another example if you want, and you can also message your teacher directly from this screen so that we can actually come and help you, where you're stuck. All right, so let's go ahead and talk about the Hinge Theorem here. So we have two triangles, and we need to decide, our angles greater than, less than, or equal to each other, our sides greater than, less than, or equal to each other, and we can do this using the Hinge Theorem. So the Hinge Theorem says that if we have two triangles like this, and they can be completely different sizes, suppose two sides of one triangle are congruent to two sides of another triangle. So, and I should have drawn that a little bit nicer like that, maybe. A little bit closer-ish. So they're not quite congruent, but these sides are congruent to each other like this. So we have the same congruent lengths, but the angles are not congruent to each other. The included angles are different sizes. So this one I'm going to say is bigger, and this one is smaller. So we don't have side angle side because we're not congruent angles. They're a little bit different sizes from each other. And what it means is that if we have this one, which is bigger than this one, then the opposite side will be bigger. And this one, opposite side, will be smaller. So we can actually use this Hinge Theorem to decide which side is larger and smaller. And then we can also go backwards. If we have the side lengths, this is the converse of the Hinge Theorem, then we can go backwards and say that the angles will be bigger or smaller based on the bigger or smaller side. And this all has to do with when I make an angle, so let's call this 30 degrees. Well, if I make, and I connect this like this, if I make this angle bigger, this side length gets a little bigger. If I make the angle smaller, the side length gets smaller. So it has to do literally with changing the rays and making that angle bigger or smaller. So it's just that kind of practice in that. So we're just going to pick a few things here. We're going to go through and take a look at this. So we have angle ABD, so this angle up here, and angle CBD, so this angle up here. So we're looking at the angle, so we want to go opposite sides, and I have 5 and I have 4. So across from ABD is 5. That's bigger than 4. So ABD is going to be greater than CBD because the side opposite is bigger. That means that the rays are farther apart than the 4. Okay, so it's just one of those. We can go opposites. Let's see. We can do this next one. So we have EG and XZ. So we have 116 and 114. So 116 is going to have a larger segment opposite than 114. So EG is going to be greater than XZ. And then this last one, we have J and P. So I have 9 across from J, and I have 8 across from P. So 9 is greater than 8. So this is going to be greater. And again, they were all greater than. That's interesting. I wonder why they were all greater than. So I'm going to go ahead and go with it. Sometimes that throws us off a little bit, but hey, it worked. So yeah, having them all greater than seemed a little funny, but sometimes Alex does that. It throws us off a little bit. So it's just the idea we're just looking at. If we're looking at angles, go across. Which one has the greater side length? That's the greater one. Or if you're looking at angles, starting with angles, which is the greater angle to go across to the greater side length. So that's the idea of the Hinge theorem. All right, well, that was section 6. I believe we are all done with chapter 7. So I will see you next semester.